Figure 7 shows a sketch of triangle OAB, and the point C is such that OC is 2OA. So I'm going to go along OA and then the same distance again to get to C, about there. The point M is then the midpoint of AB, and the straight line through C and M cuts OB at the point N. Like that. We're given that OA is equal to A, and OB is equal to B. I'm also going to add on that this here is A, because we're told that implied here. Find CM in terms of A and B. So C to M, well, what we can do is go minus A and then half of A to B. Let's first find out A to B. That's going to be minus A plus B, or B minus A. It's always the second minus the first, but I think using a diagram is always useful. And that means that AM is going to be half of that because M is the midpoint. So then CM is going to be minus A plus that, which will give me, I'll write it as a half B minus 3 over 2A. We're then asked to show that ON can be written like this. Now, one way to get from O to N is simply to go in the direction of B, but it's not wanting us to do that because there's an A term in there. So we've got to think about another way, and it's surely to use the part A to help us. To get from O to N, we can go from O to C, so that'll be 2A, and then we're going to go some multiple of C to M. Okay, actually we're going to go a little bit further, and that's where my lambda is going to come in. So ON is going to be 2A plus some multiple of CM. That's 2A plus half lambda B minus 3 over 2 lambda A. And I can bring the A's together. I'm going to get 2 minus 3 over 2 lambda, all multiplied by vector A, plus a half. By the way, I strongly advise you underline your vectors just to make it clear which are the vectors and which are not. Of course, it's bold in the question, but we can't do that very easily. So this is our notation. So, okay, we managed to get it. I should probably have just said here lambda a scalar multiple. I know it's defined it in the question, but I'm just defining it here as well. Hence prove that ON to NB is in the ratio 2 to 1. So to do this, I've got ON involving a scalar. I'm going to write down ON as another multiple. It's actually just going to be a multiple of B. I'm going to write it as mu B. And then I can set them equal to one another. Now it can be shown that if you get this sort of equation and A and B are not parallel, then it must be that the B components are equal. So a half lambda must equal mu. And the A components are equal. There is no A component over here, so I guess we could write 0A. Actually, it's going to be that 2 minus 3 over 2 lambda equals 0. Now, to be fair, you could have avoided doing ON equals mu B. You might be thinking, why have you introduced that? Because we can see that there is no A component. You could have gone straight there and said that. But I'm using this method. It's useful in other circumstances. When I did it, that was just kind of my go-to. But don't worry if you don't do that. So that means 3 over 2 lambda is going to equal 2. lambda is going to be 4/3. You then put it back in to get it to get on. Therefore, on is going to be this bit 0. Remember, it's a half of 4/3. It's going to be 2/3b. The alternative is to work out what lambda is. What mu is by doing a half of it and then putting it back into this one. You get exactly the same thing. So I've kind of talked about the two different approaches here. I hope they are making sense. Either like the first one, just don't worry about a mu. Just realize that we can set this equal to 0, solve to find lambda as 4/3, put it back in to get on as 2/3 b. Second method, the one that I've kind of hinted towards, write down mu b, like equate the coefficients, work out lambda, put it back in to get mu, and then we get that on is 2/3 b that way. Either's fine. But what we see, therefore, is that on is going to be 2/3 b, which means nb is going to be the rest of it. nb is going to be 1/3 b. And hence, on to nb is going to be 2/3 to 1/3, which we can simplify to 2 to 1 as required. I just want to talk very briefly about this, this idea of using a mu. It's going to be useful on slightly harder questions where you have maybe 3D solids and similar. So it is just worth being aware of. It won't always just cancel out nicely. We won't have a horizontal vector. There will be times when it's necessary. So, take on board both methods thinking this question, even though it's only a couple of marks. So it's kind of probably saying, yeah, just set the a component equal to 0, it's good to see both ways. Okay, well done.